George Powell, who is an independent consulting agrologist with over 30 years of experience in delivering research and development support for agriculture. He specializes in integrated production systems and blending conservation and production practices. George has a PhD from the University of Alberta in agroforestry, as well as degrees from the University of British Columbia in rangeland ecology and agronomy. And I will pass it over to you, George. Thank you.
Thank you, Harmony. So thank you everyone for attending this evening. This presentation, I'm going to focus on some soil moisture, soil water conservation strategies through building your soil organics and tilth, that is the structure of the soil. We're going to start by just going through some of the basics of soil tilth and the role that organic matter plays in healthy soils, and explain to you how healthy soils will trap and hold soil moisture. They will in fact build the capacity of your farm to slow down and hold moisture. And then we're going to go through some management options for adding and retaining soil organics and building tilth on the farm, with an emphasis on the practical for the central interior of British Columbia. So tilth is a very old word. In its original meaning, it was land that is suitable to cultivate. In the modern context, it's the physical condition of soil in relation to its suitability for growing a crop. And this applies equally to cropland, pasture, or rangeland. And good tilth is important because it contributes to optimal crop production. So plants with good tilth have good plant soil contact. It's firm enough so that you have direct root soil contact, allow the roots to feed, pull in water and nutrients, but it's loose enough to allow them to forage and move around so that root growth is still able to happen. Soils with good tilth have good water movement and retention, which is really the focus of tonight's talk. The pores that are in the soil are large enough to allow water to enter and move in, but small enough to hold on to the surplus for later use. And soils with good tilth have really good, stable air spaces. And air space is equally important in the soil to exchange gases and to aid with soil warming. Indicators of tilth. So tilth is a complex, interrelated set of factors. We've broken it down into 6 factors, 3 on the geological side, 3 on the biological side, and we'll go through these in details. But soil particle side, the structure and density on the physical or geological side, and then organic matter, root networks, and soil organisms on the biological side. Soil particles, so just some basics here so that everyone's on the same page. Soil particles based on size start at the microscopic, being clay particles. Up to about the size of a pencil dot on your paper would be a silt particle. And then things have a grain of sand or a salt or a sugar granule are declared sand particles. And the relative proportions in your soil of clay, silt, and sand gives you the soil texture. So right in the middle, sort of roughly equal proportions of silt, clay, and sand would, using this triangle from the USDA, would give us a clay loam. Soil particles are important because they really determine how well your soil is going to aggregate and form structures. So clays, if you look at them, and I have a photo here under a scanning electron microscope, at that tiny level, they look like tiny plates. And the surfaces of those plates, when they come into contact with each other, can form really strong chemical bonds. So they aggregate together into more complex structures. Silts, clays, and these clay aggregates can also be bound into more complex structures with organic glues. And we would refer to these as soil granules, also known sometimes as soil crumbs. And they have a variety of pore space and substructures within them. So this is important because it determines the substructures, and the physical components determines the structure, which really strongly influences the pore space and the movement of air and water through the soil. So if you have a very heavy clay soil, those clay particles, with the absence of other particles or organics, tend to aggregate into very large structures, either a massive or in platey, large plates of soil. And it's very difficult for water to move through those types of structures. If you have some additional content of sand or silts or a bit of organics, those clays start to break apart into blocks or prisms. So you still have really a small pore space within those blocks or prisms, but you have larger pores and openings between them. So water movement is going through, but your whole soil profile isn't accessible to plants with those types of structures. You can also have at the other end soils without much structure at all. So if you think of a pure sand or entirely organics, it would be considered a single grain. So you have good water penetration, but in the case of the absence of organics, that water tends to move through rather quickly as well. With granular structures, the one that we're trying to focus on in building tilth, we have a good mix. So it has the openness, the pore space to allow that water to come in, but it has a variety of particles and openings within the soil matrix to retain that water. So it's a little bit like the Goldilocks scenario. So large aggregates are of poor structure because the spaces within them are too small. And if in the case of prismatic or blocky soils, the spaces between them are too large. If you have no aggregates at the opposite end of the spectrum, a pure sandfur soil, these are problematic because the soil matrix is too easily disturbed. It doesn't form stable structures to allow your root foraging optimally. So what we're looking for is medium or small aggregates. This is best overall for plant growth. Soil density also has a very strong influence on tilth. So the ideal soil is equal parts solids and openings or pores. And that pore space decreases with increasing soil density or compaction because this leaves less space for roots, air, and water. Organic matter is really a keystone element to your soil tilth because it catalyzes other elements and has a strong influence on both the biological and the geological components of tilth. So as organics decompose in your soil, they're releasing sugars and nutrients that feed soil organisms, and we'll go over in just a second the importance of soil organisms in building your tilth. They release polymers and complex carbohydrates that are acting like a glue that holds soil particles into those good aggregates. So if you think, take a little bit of cornstarch or flour and wet it between your fingers, it's slightly sticky. The starch component has like a very weak glue property to it, not overly bound, but not loose and with a lack of structure. And also when they break down organic matters, release organic acids, and these can in fact break the chemical bonds that bind the clay particles tightly together. So it's working on many different levels to improve your tilth. Root networks are a good indicator of tilth. And some benefits of a healthy root network, up to half of the root mass on a plant can be composed of fine root hairs. And those root hairs can in fact turn over every year. So they'll grow new root hairs and then release and allow them to decompose. So that's contributing a lot of organics to the soil from a healthy root network. Root expansion will actually break apart large aggregates. And with trees and shrubs, there's enough hydrostatic pressure inside those roots that when they're expanding, they can crack rocks. And the root cavities that are created from growing and moving and decaying creates pathways for soil organisms to move around and allowing them to do their job in contributions to soil tilth. Organisms. So soil organisms help us build tilth because they're a decomposer of organic matter into the humus or the soil organic matter and those organic acids, those important components for the soil chemistry. Microbes deposit organic residues that also act as an aggregate for soil particles. So they're acting like that glue that holds the particles and groups of particles into good aggregates. And of course, your larger creatures, think insects or worms or small mammals, are creating cavities and mixing the soil for you. So they're churning and turning and breaking apart the bad aggregates and allowing things to aerate and have that pore space that's important. So how does this relate then to soil moisture conservation? So organics and tilth work on many levels to help conserve water. So that organic matter pool on the surface slows surface water flows. So and organics and plant material intercept runoff. They slow evaporation by covering the soil surface. And they increase the infiltration and diffusion of water down into groundwater, into the soil water. And as that organic matter decomposes into soil organic matter, or SOM, it actually creates a reservoir within the soil that improves soil water storage, so that organics act in that case like a sponge, holding on to that additional water for later use. And what's really key here, and what we're going on through in the bulk of the presentation here, is that how you manage your conservation areas, your livestock, your crops, all determines whether you're going to add to or diminish that organic matter pool. So water loss through evaporation is a function of the area that's exposed, so the amount of bare soil, and the evaporation rate. Surface organics reduce the area exposed. It's like a cover, a blanket over top of the soil. It also cools the soil surface and elevates the humidity, so that reduces your evaporation rate. So this is an example of some mixed herbal crops, and here you can see they actually have plastic on the rows and a straw mulch between the rows. So and you have many options: organic mulches, crop residues, perennial vegetation. The point here being is that organic, be it living or decomposing, is covering the soil surface. Surface organics and the living component intercept surface flows, so they become a physical barrier, increase friction to water movement. And as water slows, it is more likely to soak into the ground. So your infiltration rate increases with slower moving water. Soil organics and tilth also improve infiltration at that top layer of the soil, so that increased porosity allows openings for water to move in. And they do this directly and indirectly, so that they're pushing apart those dense aggregates. They're also feeding soil organisms, which are churning and opening the soil for you. That's the indirect effect on porosity. They decrease surface crusting, a form of bad aggregate, which in some cases seals the soil layer, so that you might have subsurface soil that's ideal, but a surface crust prevents that surface water from penetrating. And the organic component acts like a sponge, and it will actually wick water from the surface down into the rooting zone of your crops. And the effect is quite profound. So I pulled this table from the Food and Agriculture Organization. And you can see with clays or highly compacted soils, your maximum infiltration rate is up to about 5 millimeters of moisture per hour going into the soil. So if you've got rainfall in excess of 5 millimeters per hour, that excess doesn't go into the soil, it runs off. And then as you move to larger particle size, from your clays to your loams to your sand, that infiltration rate increases. Key here is that your organics are on par in terms of infiltration rates with sand, with the loosest soil structure. But they have the added benefit of being able to retain some of that water in the crop rooting zone. So it's not, with sand, you get a high pass-through rate, it lets the water in, but it moves on very quickly. With organics, you have a high infiltration rate and a high retention rate. So just to demonstrate that, this some research that was published by Hudson in the Journal of Soil and Water Conservation. The absolute numbers here are not that important as the trends. So if we look here, this graph is showing soil water content over a range of soil organic carbon levels in two different soils, a sand and a silt loam. The bottom line, the permanent wilting point, is the point beyond which the soil is too dry to support plant life. The plants can't pull enough water up with their transpiration stream and they wilt. The top line represents field capacity. At that point, the plant can't make any additional use of that water. So the plant available water is the area between those two lines, the wilting point and field capacity. And so what you see, these numbers represent about 0.3% increase in soil carbon, and you double the water holding capacity in these two soils. And so the USDA, as sort of a rule of thumb, estimate that with each percentage organic matter, you can store 16,500 to 25,000 of gallon of water per acre. This is the equivalent to about 1/6 of an acre foot. Now that number might seem insignificant, but it's not really. I think if you had soil organic matter content of 3%, which is an attainable value in the central interior, you would have buffered about a half an acre foot of water on your land. Why is that value important? Rule of thumb for the central interior, you need about 1 acre foot of water to grow a good forage crop each year. So if you think about that, by having those organics in your soil, you've already buffered at the end of snowmelt, the runoff season, half of your soil water needs for your crop. No additional irrigation or rainfall inputs, just by having that soil organics component there. So we go now and shift and look at some of your management options for improving tilth, principally through adding organics, but a couple of options outside of the organic realm. Very much your options for building tilth though are going to depend on the soil type, your production goals, and your budget. If money is no object, I can turn a parking lot into a very productive agricultural field. I'm going to assume for most of you, money is an object. So what I've done is emphasize no or low cost options for adding organics and building tilth. And we put tilth improvement options into 5 categories. Direct additions of organic matter, retaining the organic matter that you already have, tilling smart and sparingly, avoiding compaction, and some options for inorganic additions to improve tilth. At the outset, I think it's important to set a goal where you want to be in terms of your soil organic matter. If you're not measuring it, you're not really managing it. So what I've done here, with temperate soils across the globe, your soil organic matter will range below 0.5% up to a maximum of about 10% in mineral soils. Those numbers at the high end are not really realistic in the central interior of BC. Our soils are too young, and the vegetation complex that was there before we cleared them for agriculture was not conducive to a lot of organic accumulation. But in terms of a overall percentage, if you have a soil without a significant clay component, so on your soil texture triangle, you're below 30% in clay, just go by the raw percentage of organics you have in your soil. If you're below 1%, you're going to be challenged in your agricultural production. Up to about 2% is good, up to 4% better, and greater than 4% is best. If you do have a significant clay component in your soil, those clay particles are really going to dominate tilth and soil structure. So I've adapted this from some recent research that was published in the European Journal of Soil Science. And what we look at here is the ratio of soil organic matter to the clay in the soil. So that ratio becomes more important than the absolute percentage of organics that you have. So if you have less than 1 part organic to 13 part clay, your production is going to be challenged. Going up the line, if you have more than 1 part organics to clay, that's your best or optimal production, because again, those organics are going to aid in breaking and disrupting those bad aggregates that clays can form. Options for adding organic matter, there's a lot. And I think from a practical standpoint, go with what is cheapest and most available to you given your resources at hand. So livestock manure, composted manure or composted vegetation, biochar, we called that charcoal when I was a kid, peat moss, straw, deciduous leaves, sawdust, bark mulch, and wood chips. I use these sparingly. I'll go over the details for that in a minute, but it relates to your carbon nitrogen ratios and the pH effects that can have from putting too much of these down. Because there's a lot of forest industry in the central interior, some of you have outlets to get pulp mill sludge or fly ash. These are both appropriate amendments if they're used properly, but you need to use caution. And my principal concern there, which I'll go over in detail in a couple of slides, is the amount of heavy metals that you might be bringing with those 2 amendments. And then there's limited opportunities actually in the central interior to bring in sewage, sludge, or biosolids, but you need to use extra caution with those because some of the other things that come along for a ride when you add that organic source to your soils. What I do not recommend you using, night soil. which is the fancy soil scientist term for human waste. Uncomposted animal tissues. They transmit disease. They can also attract pests to your property. Uncomposted or composted specified risk material. So that's the spinal column and the brain of certain livestock species at a certain age. And the reason for that is that they may carry prions. Prions are not destroyed in the composting process, and then you therefore have a risk of passing on things like mad cow disease or other brain wasting diseases to human populations or to livestock populations. Do not use shavings or compost if it's made with treated wood. And do not use any organic source if it has been mixed with garbage or inorganic waste, so concrete, plastic, gyprock, rock wool, or anything else. All of these pose a health or environmental hazard, best to avoid. So, in adding organic matter, is there such a thing as too much of a good thing? Yes, if you do it all at once. So you really have to watch your carbon-nitrogen ratios. Carbon and nitrogen in the interior BC will settle out at about 12 to 1, 12 parts carbon to 1 part nitrogen. If you increase it above 30 to 1, what you're doing is giving a lot of food to those microorganisms in your soil, to the bacteria, to the fungi in the soil, and their population booms, and in so doing, they start to suck up the free nitrogen that's in the soil and immobilize it for their own benefit. That means that you're going to have, on a temporary basis, because it will settle back down to that 12 to 1 ratio after a year or two, but you're going to have on the short term a nitrogen deficiency in your soil. So again, you can look up these values fairly readily for different materials on the internet, but as an example, raw wood has a ratio of 300 parts carbon to 1 part nitrogen. So if you're putting raw wood or wood chips or sawdust into your fields, you need to balance that out with some additional nitrogen, or you're going to skew the CN ratios. You also really want to pay attention to what else is being added when you're adding a carbon soil amendment. So with manures, we have a persistent problem throughout BC, not just the central interior, of excess phosphorus and potassium, in some cases salts that come in with manures. That's because the predominant manures that are used are fairly low in nitrogen, and so when you add a lot to try and get your nitrogen content up for the plant, you're adding a real big excess of the P and K. And that excess can leach out, become an environmental problem. In some cases, it becomes a problem for your crop production. With some of those bioamendments that come from the forest industry, your pulp, sludge, or fly ash, you really have to be careful about heavy metals coming onto the farm. So there is naturally occurring throughout the forests tiny amounts of lead, cadmium, arsenic, other heavy metals, and they get pulled up into trees. When the trees are harvested and taken and processed, so as an example for paper, those heavy metals fall out and settle into the pulp sludge. So when you're taking that pulp sludge and putting it on your property, you are going to bring a small amount of those heavy metals with it. Now, legally, you have to have an approved soil amendment plan before you can take that pulp sludge or fly ash from the industry and put it onto your farm. What I've seen occasionally is that after the truck passes the farm gate, farmer will say, well, if a little bit is good, a lot must be really good. Not realizing that those recommendations for application rates are based in part by making sure you're not toxifying your land with heavy metals. And the same goes, but double, for sewage sludge. If you have a source coming from a municipal, or even if you're pulling it out of your own septic lagoon and thinking about applying it, just think that everything that's in that sewage sludge was originally flushed down someone's toilet. And even in the soil amendment plans, they don't necessarily test for everything that could potentially end up in those biosolids. So there's toxins, microplastics, pharmaceuticals that go through undigested, and they're going to end up in your fields. In all cases, I highly recommend, if you're a significant user of organics for your fields, you should develop and follow a nutrient management plan. So you're going to, a nutrient management basically is a process of balancing out what can be reasonably assumed to be taken up by the crop, what's in the soil, and what you're adding. It's kind of a tricky process with nutrient management, some case with purely organic situations, because the nutrients are not in perfect balance in the nutrient source relative to what your crop's going to take up. It's a little easier if you blend synthetic fertilizers with organic fertilizers. Other options for adding organic matter. You can do it through cropping practices and managing crop and feed residues. So purpose-grown green manure crops or plow-down crops, you essentially just grow a crop on your field and turn it into the ground to feed the soil. That, of course, does come at a cost, an opportunity cost, because that field is not generating an economic harvest, but over the long run, it's something that where you're building the organics of your soil. Harvested crop residues, so that's just a matter of changing how much you harvest at the time of harvest and leaving a little bit to feed the soil again. So that might mean foregoing the last cutting of hay, or it might mean with a gray crop, taking the grain off and leaving the straw to be incorporated back into the soil or decompose on the soil. And then with livestock feeding, there's a whole variety of in-field livestock feeding systems where you move the feed out in the winter period onto crops or pasture land, bale grazing, swath grazing, rolling, chopping, lots of different variations of that. But in essence, those crop residues will then capture and mix with livestock manure and urine. You're capturing nutrients, you're adding organics, and contributing to soil building. Agroforestry is a good option for many for adding organic matter. We're talking about shelter belts, hedgerows, riparian buffers, and other integrations of trees and shrubs. They all add organic matter. The deciduous trees and shrubs will add leaves and litter fall every fall right now. There's a rain of falls outside my window, leaves outside my window right now. And as I previously discussed, the root turnover. Because they're very big plants, they're generating a lot of soil organics on an annual basis for you. Managing your grazing to add organics. I recommend that you set stocking rates to leave a minimum 25% stubble and litter if you want to be in a building phase. I have some producers that have told me they go as high as 50%. So 50% feed your animals, 50% feed your soil. You always want to use rest and rotation on your pastures and rangeland. Intensive grazing systems, some of these short duration mob grazing strategies may enhance organic deposits depending on the vegetation complex that you're grazing. Some plants are stimulated by grazing, others are not and need a longer recovery period. And you also have to balance out the potential for organic matter additions to soil tilth versus the risk of compaction. So some ill-timed grazing, particularly with really heavy mob-style grazing on wet soils, heavy clay soils, may actually do some compaction damage. Just before I leave the organic matter section, I want to discuss, should we compost or not compost before you add it? So in situ decomposition, so that means decomposing plant materials or animal waste in place from infield feeding, crop residues, adding raw manures, either you add them or the livestock add them, they generate some transient beneficial biochemicals, those starches and organic acids. As they're decomposing, they're releasing stuff that have a positive effect on your soil. If you're adding to your soil a finished compost or well-rotted organics, something like very well-aged manure, they do not add as many because they've done some of that decomposition and those transient chemicals are gone. And if you make elemental carbon additions, something like biochar, they add none directly. So you'd get that transient benefit with decomposition in place, but the trade-off is that the less decomposed, the greater the risk for on-site or off-site impacts. So as we previously discussed, you can push your carbon-nitrogen ratios out of balance. If you have an excess of nutrients going down at once, you've got that potential for leaching and runoff. And those disappear when you add, or less prominent when you add things that are closer to elemental carbon. So again, no right answer here. It's about trying to find what's right for your individual situation. Add those organics, but then retain them. So that means undertaking practices so that you're not promoting rapid decomposition and loss of that soil carbon. Don't overrate your soil, over aerate it. This promotes that decomposition by putting too much air in there. Again, you're going to get a flourish of soil microorganisms which decompose and send a lot of the carbon up in the atmosphere as either carbon monoxide or carbon dioxide. Don't overgraze or graze repeatedly without any rest. Again, too much stress on the plant, you're going to reduce the size of its root zone, and it's going to take its own carbon reserves to regrow, not shed those into the soil and feed the soil. And don't burn too frequently. I am not anti-burning. It is an appropriate tool in some places. But don't, as I see all too frequently in the spring, burn your pastures, the same piece of ground every spring over and over again. That is not beneficial. You are again throwing a lot of carbon into the atmosphere, and there is no net benefit to the soil. So there's no reason in a pasture rejuvenation sense, for example, taking out rosebush or snowberries on your pastures, to do that more than once every 15 to 20 years in the central interior. And there's no reason at all to burn cultivated land except as an emergency pest management tool. So if you had a novel disease or insect outbreak and there's no chemical controls available for it, the recommendation might be for you to burn them off, to destroy them. But otherwise, there's no real strong reason to do any burning of crop residues in a cultivated area. Protect your soil aggregates. So conventional tillage can be problematic. The compaction that it causes, repeated compaction causes a plow pan or an impermeable layer further down. It breaks down the good soil aggregates, it disrupts roots, and it disrupts soil organism networks. But tillage is not universally bad. So again, I'm sort of a fence sitter on a lot of these issues. It works in some cases and not others. But deep tillage is a good option to bury crop pests, so as a non-chemical control means. Ripping to break up compaction layers. So tillage and similarly mixing organic matter into heavy clay soils. When you've got soil that's in a poor state of tilth, it might take a long time for it to naturally rejuvenate itself, even if you're adding those organics. Or you will get the soil building up on the surface and not penetrating down lower to layer. So a little bit of ripping and mixing will speed that process of recovery along. And with no-till systems in crop production, weed control really relies in a lot of cases on heavy chemical inputs. So if you want to avoid that, tillage and cultivation are a cost-effective and meaningful way to keep your weeds in check. So what we want to do is till smart and sparingly. So the compaction, the destruction of these aggregates very much depends on the downward force applied and your equipment weight. So use the right implement. Don't use a plow where a disc can do the job. Don't use a disc where a harrow can do the job. And time your tillage relative to soil moisture. You want the soil to be moist but not saturated. If it's either too wet or too dry, you're going to destroy good aggregates or cause compaction, particularly when you've got a significant clay component in your soil. Tilth on the inorganic front, and these I add more out of a sense of completeness. These are going to be costly because not many farmers are going to have the resources to do this for free, but you can add sand to break up clay. This really is only practical on very small plots, and it will require a considerable amount of movement of sand to adjust the volume of clay. I've only seen it done in a golf course professionally. Otherwise, it's maybe tiny garden plots. And you can add what are called polyvalent cations, which is a $10 word. A cation is a positively charged ion in the soil. Polyvalent means that the charge on it is greater than 1. So calcium and magnesium are examples of this. They come from the additions of lime, gypsum, Epsom salts. These act like organic acids to break clay soils apart at the chemical level. They break the chemical bonds on the soil surface. Main disadvantage here is cost. You have to purchase them, and when you're going strictly with an inorganic, you also are not building the system capacity as you are with organics. With organics, you're catalyzing other things like soil organisms to do some more work for you. These inorganic additions don't do that. Tilth and soil organics have many co-benefits. First and foremost, they improve fertility. This entire presentation I've given on a number of occasions, and when I'm presenting to producers and talking about building soil fertility, it is not substantially different from what I'm talking about you tonight to build water holding capacity. The two go hand in hand. When you have organic additions and good tilth, you have improved fertility. It releases nitrogen and phosphorus that's in the organics as they break down or mineralize, and other essential plant nutrients. You greatly reduce soil erosion by having your soil covered in organics, so that mulching effect. So the universal soil erosion equation factors in about 95% of the erosion capacity comes from bare soil. If you eliminate bare soil, you eliminate 95% of the erosive capacity from water or wind. And soil organics also contribute to supporting biodiversity, greater variety of life and microbes, all the way up to small mammals, and they sequester carbon, so you're helping to mitigate climate change. In all things, try to be adaptive and opportunistic. Some people use opportunistic as a pejorative term. I think it's a good term. So agriculture is both a science and an art. I do not have cookbook prescriptions that I can hand to you for building your soil organics. You're going to have to do a bit of trial and error. Everybody has different costs. Everybody has different resources at hand, different amount of time in order to apply to their soil management. So find what works for you. And adopting any beneficial practice never has to be an all or none approach. Just like that diagram or photo I had showed earlier in a herbal production setting, blend organics with inorganics. Put a plastic mulch down and use an inorganic mulch. If you want to take advantage of agroforestry, you don't have to put it over 100% of your property. Use it where you feel it's appropriate. Take advantage of opportunities as they arise and keep your costs down and look at the long-term trajectory of your soil organics and tilth. And be patient. Some practices are going to show immediate results. If you mulch in a market garden setting, for example, you're going to see soil moisture conservation immediately by covering that soil surface. Others, changing grazing practices or changing how you manage your residues, might take years before you start to see a turnaround in your soil. The beautiful thing about tilth is that the factors reinforce each other. So once it starts building, it gets easier to increase because of positive feedback loops. I add organics to my soil. That increases the amount of soil organisms. Those soil organisms aid in breaking apart and loosening the soil, which allows for better crop growth, which in turn adds more organics back to the soil. So once you get the system moving in the right direction with soil organics and soil tilth, it keeps moving that way unless you impede it with something else. And with that, I'd be happy to take your questions or comments. I always appreciate hearing for how different people around the region have approached their soil management.